There it goes. Okay, so the first slide, I mean, nothing you really need to write down here. This is just kind of a review of some terminology that you've seen in the past. So in general, what you want to remember is inequalities, we're getting ranges of solutions because something's less than or greater than, there's lots of different numbers that we can plug in to make something true. So instead of, and it's occasional that you'll get maybe a single value that's an answer, but instead of getting it one answer, we usually are going to get a range of answers. And when we list our answers, we're going to list them in interval notation, like we've practiced with our domain and range. So instead of the less than or equal to, greater than or equal to, less than, greater than symbols you've used in the past, we're just going to use brackets if it's equal to, parentheses if it's not equal to, and we're going to do the same thing on the number line also when we graph it, just so everything's really consistent as we go through, okay? We call the inequality inconsistent if there's no solution. We saw that before when we did like parallel lines. We said the system was inconsistent. And we call it an identity if it has all real numbers that are solutions. So if every number on a number line we can plug in and make it true, that inequality is called an identity. All right, so let's practice solving these. The steps to solving these are the same as just solving a linear equation. You just need to remember that if you multiply or divide both sides by a negative, that inequality sign is going to flip. Okay, so just kind of keep that in the back of your head. Both sides by a negative is when it flips. All right, so in this one, if it was an equal sign, first thing I would do is just distribute. We're going to start with that. 3x minus 9 less than or equal to 3 minus x. And then, again, I always like to keep my x's positive if I can. If it's an x squared, I like to keep that positive. So I'm going to move the x from the right over to the left side, which will give me a 4x minus 9 less than or equal to 3. Then I'm going to add 9, 12, and then divide by 4. I get x less than or equal to 3. Okay, so here's how we make our answer. I'm going to graph it on the number line first. I'm going to find 3 somewhere on the number line. It's a bracket because it's equal to, and then because it's less than, we're shading to the left. So the bracket on your number line is going to open to the left because we shade to the left. It would open to the right if we were going to shade to the right. Then what's shaded there corresponds directly to what we're going to write in interval notation. What's shaded is everything from negative infinity all the way up to 3 with a bracket. So that's how we write our answer. Negative infinity all the way to 3 with a bracket. And that's it. If you want to check it, pick a number in that range, like pick 0 would work. Plug it in, make sure you get a true statement. Any questions? All right, let's try a couple of these. These ones have fractions. An optional, but I would say good step to use here is to multiply through the least common denominator, like we were practicing with those rational problems. It's going to make the numbers a little bit bigger, but it's also going to get rid of all the denominators. So in reality, it's making the problem a little easier to solve. So in this first problem, remember that 2 is over 1. What's my least common denominator? Okay, 3, 2, 1, common denominator is 6. Yep. So we're looking for a number that 3 and 2 both divide evenly into, and 6 is the smallest one. So I'm going to multiply everything in this fraction by 6. Now remember that 6 is in the numerator, multiplying by 6 over 1. So when it goes in the numerator, let's say it goes in this guy over here, I'm not going to distribute it in. I have a 6 on top and I have a 3 on the bottom. I can reduce that. 6 over 3 reduces to 2. And then that x minus 3 I'm just going to bring down. Okay, in the next fraction, if I have a 6 on top and a 2 on the bottom, what does that reduce to? 6x over 2, which reduces to 3, and then there'll be an x. And then finally, 6 times 2. Nothing reduces there, but we can do 6 times 2. We get 12. Okay, so you don't have to do this step. You can solve it with the fractions, but I think it's a lot nicer when you get the whole numbers. From there, then, we just solve as usual. So we're going to distribute 2x minus 6 less than or equal to 3x plus 12. Again, I like to keep my x positive, so I'm going to move the 2x over to the right, just making an x plus 12. Don't forget to bring that negative down with the 6. And then subtract 12. So I'm going to get x is greater than or equal to negative 18. Some people will look at this and say, well, the x is on the right and the number's on the left, so it's got to be a less than. It's not a less than because our little alligator mouth right is opening up towards the x, so x is greater than. If you want your shading to match up with your inequality symbol, some like middle school teachers teach it this way, your variable always needs to be on the left side. So I can do that if I flip the inequality symbol, okay? So that maybe would make it easier to read, but the x always has to be, or whatever the variable is, always has to be on the left if you want your shading to match the direction that you see with your inequality sign. That's optional again too. So negative 18, it's a bracket because it's equal to, greater than, shade to the right, and then an interval notation that would look like negative 18 with a bracket. Infinities are always parentheses. All right, you guys try the next one real quick. Multiply by a least common denominator, reduce, and solve. And we'll put the answer up in a minute. Let's check it. I got 7/4 or 1.75, parentheses, to infinity on that one. You're going to notice if when you've got variables on both sides, you try to keep that x term positive, no matter which side that is, you won't have to worry about that dividing by a negative issue very much, unless it's already kind of built in with the x. Most of the time, you're going to kind of avoid that. So that's nice too. What questions do we have on this problem? Anything? For these problems, no, but on Monday we're gonna have ones that are a little bit more complicated, and the answer is yes for those. So it's good to just practice it for now. And on Math Excel, I think you're gonna have like some matching with your answer choices too, so good to kind of know what it looks like. Okay. Anything else on this? All right, we got 3 more slides. Okay, so the next slide is review of what a compound inequality is. This is where we use the words and versus or. If you see an or statement in an inequality means union, and it means both statements put together. We do not care if they overlap or not. It's just both parts of the solution graphed together. If it is a solution to one, it is a solution to the whole. So anything that is a solution to either piece is part of your final answer. If it's an and statement, that's where we're talking about an intersection. So we are only looking for what the 2 pieces of our inequality have in common. Only where they overlap would be part of our final answer. So unions, everybody put together. Intersection is only where they overlap. So again, this is going to be maybe where it's helpful to get a graph of it just so you can kind of visualize where those intersections and things are happening. When we solve these, we solve the 2 little pieces independently, just like we practiced. So if I start with this guy on the left, 3x minus 5 greater than or equal to 7, I'm just going to get that x alone as usual. So I'm going to add 5, that gives me 12. I'm going to divide by 3, that gives me 4. And I'm just going to leave it like that. I'm also going to bring down my or statement. Okay. On the other side, to solve for x, I would need to first, it's a positive 5, so subtract 5, which would give me a negative 4. And then here we have no choice but to divide by that negative. And when I divide by the negative, what's going to happen? My sign's going to flip the other direction. Well, remember that. Okay, so I think it's helpful to graph both of these on the number line before you write your final answer. If I'm graphing x greater than or equal to 4, I find 4. It's a bracket because it's equal to, and I shade to the right. If I'm graphing x less than or equal to 2, I find 2, bracket, opening left, and I shade to the left. Then I look at my statement. This is an OR statement, which means anywhere that's shaded is part of my solution, whether it overlaps or not. So our final answer, and you can see how this relates really nicely to our interval notation, is just anywhere we see shading. So negative infinity to 2 is that first interval. 4 to infinity is the second interval. And remember, if we have multiple intervals, we connect it with that union symbol. That's why we use that symbol. Okay. What if this was an AND statement? What do you think my answer would be? There would be no solution, right? So it's possible if you have an AND statement and they're going opposite directions that it's just no solution because there's nowhere where the two pieces overlap. But because it's an OR statement, we're okay. All right, let's look at the next one. 2 times the quantity 3 minus x minus 3 is less than 5, and 2 times quantity x minus 5 plus 7 less than or equal to 3. Okay, solve each piece individually first. So distribute 6 minus 2x minus 3 less than 5. 6 minus 3 will give me 3 minus 2x is less than 5. Subtract 3, negative 2x is less than 2. And then divide by negative 2. Because I'm dividing by a negative, I'm going to flip my sign. X is greater than negative 1. And on the other side, 2 times x minus 5 plus 7 less than or equal to 3. I'm going to distribute my 2. 2x minus 10 plus 7 less than or equal to 3. So 2x minus 3 less than or equal to 3. Add the 3. 2x is less than 6. Divide by 2. X is less than or equal to 3. All right, and then, hold on, let me see here. Where'd my little pen go? There it goes. All right, so let's graph these. X greater than negative 1. I would find negative 1. It's greater than, not equal to, so it's a parentheses, and it's going to open to the right. Like so. X less than or equal to 3 is wherever 3 is on here. Bracket and shade to the left. Because it's an AND statement, we're looking for where the intersection is. So the parts that's shaded in both colors, I guess. So that's just what's in the middle in this case. Negative 1 to 3. It has to have both colors to be part of your solution. Negative 1 has a parentheses, 3 has a bracket. What if this was an OR statement? What would my answer be? If this said OR instead of AND.
Negative infinity to 3.
A little bit more than that, actually. Negative infinity to positive infinity. If it's an OR statement, anywhere we're shaded, doesn't matter what color it is part of our answer. So the whole number line is shaded by at least one color. So this would be an all real numbers solution, or an identity was the word we saw at the beginning of the lesson. So how we write that in interval notation is negative infinity to positive infinity if you see that whole number line shaded and it's an OR statement. Okay. These AND statements we can see written as compound inequalities like this, where we have two sets of inequalities in the actual problem. Usually we leave them like this. I'll give you an example when we don't want to leave it like this in a second. But our inequality symbols are always going to be pointing in the same direction at the smaller number. And then sometimes they're equal to, sometimes they're not. You can split it up into the AND one if you want to. I think it's easier, especially if you just have one x, to just solve the whole thing as you would an equation. Like here, I have this 5 in the denominator, so I don't want that. First thing I'm going to do is just multiply by 5 on both sides. Okay. All right, so I'm just going to multiply, instead of both sides, all three pieces of my inequality by 5. So it'd be negative 5 less than 2x minus 3. It'll cancel in the middle. Less than or equal to, it's still a 0 on that side. Then how do I get the x alone? Well, if I want to get that x alone, I need to add 3 and divide by 2. We're just going to do it to all three pieces to keep this inequality statement balanced. So that would be negative 2 less than 2x less than or equal to 3. And then I need to divide everything by 2, which would be -1 less than x less than or equal to, you can say 3/2 or you could say 1.5 there. You want to make sure, because sometimes it gets a little tricky, that the inequality symbols in your answer are pointing at the smaller number. If they are not pointing at the smaller number, it's no solution. That's not possible, okay? But -1 is smaller than 3/2, so we're okay. And then if I want to graph it, this is just saying x is between these two numbers. So -1 with the parentheses, 3/2, wherever that is with the bracket, and then we would shade between them. Okay, again, as long as my inequalities are pointing the same direction, you're good. And then that's exactly what our interval notation looks like too, just like that. -1 with the parentheses, 3/2 with the bracket. Okay, that's if I have one x, you just solve it as usual. In the next problem, we now run into some issues because there's multiple x's here. And if I start trying to move things around, it's not as simple as balancing two sides. I'm balancing 3 things, and it becomes this juggling act where you can kind of just get stuck in this like endless loop. So it is better to split it into 2 separate inequalities. The 2 pieces on the left, the 2 pieces on the right. So the one in the middle you're using twice, and you always separate it with an and statement. And you can do this with any compound inequality really if you want to. All right, so my first one is going to look like this. 5x is less than 3x plus 1. That's the first relationship we see. And also 3x plus 1 is less than 4x minus 2. Once I get it just to 2 pieces, then we can balance it like we normally do. So for the one on the left, I'm going to subtract 3x, which gives me 2x.
Hello. This is for your 7th period.
For my class of 8 through 6.
Yes, but we just looked at the other teacher. She says to put it in there.
I don't have a 7th period.
And we'll just give it back to the teacher like it was.
Okay. All right. I swear. Okay. X is, if I divide it, less than a half. For the other one, I'm going to move the 3x over to the right. 1 less than x minus 2. Add the 2. X is greater than 3. And this is an and statement. Okay. Graphing these on my number line. X is less than a half. So find a half. Parentheses. Shade to the left. X is greater than 3. 3 with the parentheses. Shade to the right. And it's an and statement. Is there an intersection? So what do we say? No solution. Okay, if it was an or statement, it would be negative infinity to a half, 3 to positive infinity. But these compound inequalities will always be an and statement. All right? Last slide. You're going to see a couple of these on Math XL where they're asking you to fill in the missing numbers on the compound inequality. So here they say, we know that -3, well, x is between -3 and 2. And we want to find a and b so that 3x plus 5 is between those two numbers. What you're going to do here is you're going to work backwards. We're not going to start with the variables. Instead, we're going to start with our given, kind of like what you did back in geometry, and we're going to build the 3x plus 5 in the middle. Okay, right now we just have an x. I want a 3x plus 5. If I can get the 3x plus 5, what I have on the ends are going to be my answer for a and b. So what would I have to do to that x to make it a 3x plus 5? What would you do first? Multiply everything by 3. So -9 less than or equal to 3x less than or equal to 6. And then what else would I have to do to build that missing piece in the middle? Add 5. So I would get, so let's see, -9 plus 5 would be -4. 3x plus 5. And 6 plus 5 would give me 11. And then that gives you your answer. You can see A, the smaller number is -4. B, the bigger number is 11. Okay. So let's do the last one. X is between, oops, it's just less than here, between 3 and 7. I want to build that 1 minus 3x. What would I have to do first? Sebastian? Yep, multiply by -3. And if I multiply by a negative, what's going to happen in my inequality? Multiply or divide by a negative, what happens? Sign flips. -9 greater than -3x greater than -21. Then what else do I have to do to create that 1 minus 3x? What's going to be my next step? How do I get that 1 there? Just add 1. That's it. So -8 greater than, you can write 1 minus 3x, positive 1 minus 3x, greater than -20. So what's my a? Yeah, you got to be careful here. A is -20 and B is -8 because my signs are pointing the opposite direction. B is the bigger number, A is the smaller number. All right, that's it for our lesson today. So as a reminder, your 1517 Math Excel, which was the absolute value equations and rational equations, that's due tonight. 16, and then second half of 17. We're going to finish that next week on Monday and Tuesday. And that Math Excel, if you want to start it, you can. That Math Excel is going to be due on Wednesday night. So you have one assignment due tonight, and then the next one's due on Wednesday. And then we're getting ready for our little one-day test next week, which is going to be on Thursday. So look ahead for that.